Hello and welcome everyone. Today we'll be taking a look at the native tool support that has been introduced in Ollama recently. You can see July 25, 2024, pretty new. And in this native tool support, you do not need any special framework like LangChain or Llama Index to do tool calling. You can natively do it now. However, there is a little bit of boilerplate code that you have to write, like you have to define your tool definition and schema and all that, so that your model is aware of these tool structures that you're going to write. However, if you wait till the end of the video, I have a way to show you how you can create your custom tool annotation and just annotate your tool, and you do not have to import the whole library of LangChain, and you can just do it using requests library. And in order for you to see all that, I'll first have to explain how the native tool calling works. So there are only a few models that support the native tool calling right now. So not all of them do that. So Llama 3.1, Mistral Nemo, Fire Function V2, which is I think the extension of Llama 3 with fine-tuned tool calling, and Command R plus version of it, so the bigger version of it. And if you go over here on the libraries for Ollama, so ollama.com/library, and click on the models, you can see all the models over here, and this is what you're looking for, the tools tag. So mostly the newer models that you have, so if you go over here and newest, most of the newest models are supporting this, including Mr. Large. This is definitely gonna need a lot of VRAM for you to run, excuse me, but definitely supports the tool over here. So Mr. Nemo, this is one of the very interesting models that you can use for your tool use if you want, but I just recommend Llama 3.1 70 billion model if you have at least 44 gigs of VRAM, or 8 billion model with the quantized version of 8K instruct version. So I have noticed that this 8K, where did it go? 8 billion, this one, instruct Q8, this is the best one that I have found as a medium, with 8.5 gigs of space. So it runs with about, I think, 10 gigs of VRAM, around that size. All right. So now that we know which models can work, let's take a look at code and let's see what does the code look like for this. So let me close all this, make this section a little bit bigger for us. So let's go to appearance and zoom in a little bit. Okay, so in order for us to run this, all we have to do is to get the requests, because we already have our Ollama server running. So Ollama server is up and running, and we can directly just import requests and start doing request responses against it. And this is our function that we are defining, right? So it is just simulating whether the weather conditions of a particular city, and we have just one input over here, and this is just a mock implementation, and this is not even a doc string over here right now, right? So I'm just going to delete it. So it is just like one single mock implementation for this tool. And then you do have to define the schema of the tool in a tools array. So this is the tricky part that many of us do not like, because we are defining the tool anyway over here, but on top of it, we also have to define this kind of structure that, hey, type function, and the function definition over here, which is name get current weather, which has to be the same name as over here, and the description that what does this particular function do, and this description is used as a logic by the large language model. Then you have to describe the parameters. In this case, you have just one parameter. So parameter type is object over here, and properties is city, right? So there is just one property that is being passed over here, and the city property is string. And you can add a description for this, that what does this actually do, right? So this is the name of the city. So all this, and then you have to say which attributes are required. So in this case, city is a mandatory attribute for this function to be executed. And this gives the function definition to our large language model. And you will see down here that when you are creating the payload for the large language model, you can specify which model you want to use. And you can specify in messages a system prompt, right? And the user prompt. And in the system prompt, you can tell that, hey, you are master at understanding whatever, and you can use available tools. And then you can pass in this tools array. And this is cool because this is the addition that we're talking about, passing of the tools in the payload structure itself. I mean, internally, even though Ollama takes it all back and then parses it as a single request, but from the user's point of view, you do not have to mess with it anymore. You can just send it as a regular tools array in this particular payload. So in your payload, you have model, messages, and tools now. So this is a new addition. And you can use the chat completions endpoint of Ollama. So wherever your Ollama is hosted, you can take your v1 and you can put this chat completions at end of it, which is the chat completions OpenAI compatible endpoint. And you don't really have to specify your OpenAI key. You can just give whatever over here. And you can send in your headers now, which is nothing. This API key is essentially nothing over here. But now when you get the response back, you will now get an extra tool calls in the response back. And this is pretty cool because now you can extract the function from that tools call. You can extract your get with a function and you can execute it, right? So this is how this whole thing works. And let's go to terminal and let's Python, let's go to this folder, cd, and this is Ollama folder, and Python Ollama.py, and we are running it against the 70 billion parameter model, I think. So it'll take a little while to load. Where did it go? There it is. So 70 billion parameter. It'll take a little while to load, but once it is done, then we can see the result back. So it takes a little while. As you can see, it's distributing it in all the 4 GPUs. And very soon we'll be having a response back over here. There we go. So model is loaded and it's now executing. And the initial load definitely takes time. Okay, so we got the response back, right? So we have now over here, I'm looking for the tool calls. There it is. The tool calls, the tool call ID, type function, and the function name is get current weather. The arguments city and Woodbury, Minnesota as the location over here. So let's run this again because the model is loaded. It won't take as much of time. And it runs again. And then it is very consistent. I've noticed the 70 billion parameter model is very consistent with the tool calling and function calling. And in this case, you can argue that, hey, you're passing just one single tool. So it's very easy for it to understand that it has to make a tool call and doesn't have to select within the bunch of tools. And you're right. And that's why I'll show you a use case where I'll add more tools and then we'll look at the behavior of the tool calling. Okay, so you saw that every single time, last 10-15 times that I ran this, it executed. Every single time it did the tool call over here. And this is pretty impressive. So 70 billion parameter, very, very, very good for tool calling. It supports a native tool calling that comes from Ollama. All right, so now let's switch to the LangChain example of how this works in the LangChain kind of domain, because you don't have to define this tool definition if you were in the LangChain domain. Let me show you what I'm talking about. So there is the tool calling example that I showed you guys earlier in the previous video. And over there, you just define your tool and you annotate it with @tool. And all you have to do is you can create a model with tool, and you can bind your tools over here. And this is pretty cool, right? So LangChain provides you an interface in a way where you do not have to define the function schema, but you can just bind the model with tools, right? And which is awesome. Now, if we can do that over here, right? So if there is a way to abstract and to extract, not abstract, but to extract the function schema directly from the Python function, then we do not have to do it. And whatever LangChain is doing, it is actually just doing exactly that. It is extracting this kind of function definition from the function that you have defined over here. So the schema they are extracting using the tool. So how are they doing it? Let me show you that. So if we create a tool decorator over here, and I'm going to call that tool decorator as custom tool. And what this custom tool decorator or the custom tool annotation will do is it will extract the definition of the tool and it will put it into this particular format, which is what Ollama is expecting. So all you have to do is to just put this one single file in your project, right? Not the whole LangChain implementation or anything, just one single file in your project. And what this will let you do is this will let you define your custom tools. Right, so now you can just import this tool decorator.py. You can import the custom tool from there, and you can just decorate your existing functions with this custom tool. And this custom tool annotation will extract your docstring from here and your function attributes, inputs and outputs and everything. And if you come over here, you can see that is what it is doing. It is getting the docstring and it is getting the definition from the function, and it is putting it all together in this particular format. And then the tool definition is what it is adding on to your function. So you will see how you can just extract the tool definition part of every function, which will have this schema attached to it. So if you put a decorator custom tool to a function, to a get current weather function, let's say, now this get current weather function has this extra attribute in a way. So you can now use the tool definition extra attribute that has been added onto it on the fly, which contains that particular JSON in it. So let me show you this. So I'll uncomment this part out and I will run this particular so I need to comment this out, this line, and then I will run. Okay. Nope, just over here, and I'm gonna run this tool decorator tools.py, which is just printing out the tool definition attribute for get current weather, and you will see what that looks like. So Python and tool decorator underscore tools, which is what we are in the files we are at, and this is what it prints. So you can see that it structured that particular definition just from your existing tool. So you did not have to write all that. It just structured everything and it put everything together. So now this is pretty cool because now let me comment on this out once again. And there we go. So now we can just take this particular definition part of it, so tool definition part of it, and we do not have to define the schema for every function. It makes things so easy. So if these are the two tools that we want to associate to our large language model, I will show you how to do that. So in your original example in Ollama.py, you had created this tools. You don't have to create this particular definition anymore. You can use the tool definition attribute if you are decorating any particular function with @custom tool. So let's do that. So step one would be you would just create a file with all your custom tools in one place. And then you will import custom tool annotation and just decorate every method that you want to large language model to be associated with, you want to bind with, you'll just annotate it with custom tool. So in this case, I have two methods and I have annotated both of them with the custom tool annotation over here. All right, now let's move to our main program. Over here, you have to import your method which you are trying to import, right? So this is the particular method that we are trying to associate to large language model in this case. Even though it has two different functions, I'm only showing you how to do that with one right now, but you can always put a comma and then associate multiple of them over here. But this is what is the interesting part, that tools definition now has .tool_definition in it. And this is what the schema was. So this is what this particular schema is. And as long as you have your tools extracted out of your get current weather, you are golden now, because that is what you have to pass over here. So rest of the code remains exactly same. All you have to do is to just get your tool definition out and you can pass in and run your code. So you see in this case, the code looks so cleaner. The code is small and cleaner. Just in 40 lines, you get done. You don't have to define your tools over here. You don't have to define your tool definition, your custom current tool attribute automatically, your custom tool attribute automatically extract the current definition from your methods that has been decorated, and your coding task becomes easy. So let's run this particular method now, this particular Python script now, and Python tool decorator underscore Ollama.py, and let me just keep it over here and hit enter. And this again only uses Llama 3.18b instruct Q8, right? So this will run faster. And I'm going to switch it to 70b also, maybe, I'll see, but 8b itself returns the answers just like a champ. So if you see, it is absolutely awesome. Returns the result every single time. I don't know why the instruct 8 Q8, so 8b's Q8 quantized version just works way better than Q4 quantized version. And I do not know what's the reason, but it definitely works way better than Q4. Every single time it follows the tool response back. All right. So this is something that is really awesome, because even though as much as I like LangChain, this @tools annotation was one of the biggest reason why I was using LangChain. And if I can do this natively via function calling from Ollama, I don't really need to use LangChain anymore. I can directly use requests, and I can create my own tool decorator, which is just a simple method over here, which extracts the tool definition, and it puts this new attribute tool definition on every tool that I'm using, on every method that I'm using, and then I can just associate it in the tools array and pass it in the payload. This is absolutely awesome. And being able to use 8 billion version of parameter with tool calling natively is really awesome too. So I'm gonna be, switching over from LangChain. I'll think about using LangGraph, but you can still use LangGraph. You don't have to get bound to using all the features of LangChain if you're using LangGraph. And I've went in depth and I've shown you in my previous video how you can use LangGraph just for, structuring your whole program, just for routing logic and all that, for agentic flows, but you don't have to limit yourself to using LangChain even though you are using LangGraph over here. So in some of my upcoming newer videos, even though I'll finish my LangGraph series and I will show you how to use LangGraph and LangChain together, I'm also thinking of switching over from LangChain altogether and building native Ollama agents. And I know all this was possible before too, by JSON mode and also by structured responses directly, but having the native tool used just makes things way more easier for me now. All right, I'd love to hear your guys' opinion on what would you like to see next. Please leave some comments below in the video, and I'll see you guys in the next one.